Okay, so good evening once again and welcome back to another episode of our MATHFLEX. So for today, we'll talk more about power rules. So if you would notice, I kept on mentioning power rule in our last two episodes. So for today, we'll have more exercises about power rule. So when you do derivatives, so it's very important that you know exactly when to apply power rule. Okay? So the first thing to remember that you can only apply power rule if you have a function wherein you have a variable that is raised to a constant. Again, variable raised to constant. So if you would go back to our episode 105, so you would see the difference between a constant raised to a variable and a variable raised to constant. So in this case, we have a variable raised to constant, so we can conduct a power rule or we can apply power rule. Okay? So actually the main, if you have d over dx, okay, sorry, d over dx of u raised to n, so this represents any variable raised to any constant. So the derivative of this one is actually n, okay, times u raised to n minus 1, okay? So this is our general formula for the derivatives of any functions that has, okay, that is a variable raised to constant. So let's try to apply this one. So dy over dx here is equal now to, okay, so applying this this formula, so you have 5x, okay, raised to 5 minus 1, so this will be 5x raised to 4. So this is our dy over dx. Okay. So in other, you might see also on other functions in this form. So f of x is equal to 3x squared plus 5x. So if you will take the derivative of this one, so you can simply put f prime of x is equal to, so the prime here, it states the prime here, it denotes that you have taken the derivative of each term of the function. So this is, okay, let's do it directly. So we have 3x squared, so that means 2 times 3 is 6. So 2 minus 1, that is 1, so 6x plus, okay, this one is 5. You have an exponent of 1 there, so 5. And then you have x, 1 minus 1. So this is x raised to 0, so it's equal to 1. So in other words, you have x prime of x is equal to 6x plus 5. Okay? So our third example here, okay, some of you might ask, okay, can we apply power rule here? Yes, of course, because square root of x in exponential form, okay, you can have it like f of x is equal to x raised to 1/2. Okay? So similarly, if you have square or cube root of x, so this means that this is equal to x raised to 1/3, or the cube root of x squared, so that means this is x raised to 2/3. Or if you have the 8th root of y raised to 7, so that means this is y raised to 7/8. Okay. So it so happened here that our exponent here is a fraction. So that's why in differential calculus or in any branch of mathematics, if you're taking mathematics, so it's very important to have a solid background on your basics. So say for example here, okay, you can have the power rule here, but you will always go back to the basic of adding or subtracting fractions. So let's try to do this one. So if I have f prime of x, so again power rule, so this is 1/2 x raised to 1/2 minus 1. Okay? So f prime of x then is equal to 1/2, okay, x raised to 1 half minus 1 is negative 1 half. So raised to negative 1 half. So to simplify this further, you can have it like f prime of x is equal to 1 over 2 and then x raised to 1 half. Or you can do it like this. Since x raised to 1 half is square root of x, you can have your answer like this. So this is f prime of x. Or if you want to rationalize this one, so you want to multiply both numerator and denominator by square root of x. So therefore you'll have f prime of x is equal to square root of x over 2 times square root of x times square root of x, that is x. So either way, you can leave your answer like this or on this part. Okay? So I think that's a quick review of our power rule when it comes to derivatives. So we'll do more of this on our succeeding videos. So I hope you like this particular video, and don't forget to hit that notification bell and subscribe, of course. So until next time, guys, bye-bye.